women, children, friends, neighbors. These are the 1.25 million. These are the faces of type 1 diabetes in America. I'm Hannah Sides with PCB News, bringing you the latest on diabetes care and prevention. Type 1 diabetes is an autoimmune disease that affects nearly 1.25 million Americans. This occurs when the body does not recognize the pancreas as its own and begins to destroy the beta cells, which normally function to produce insulin. Without this life-sustaining insulin, glucose builds up in the bloodstream, unable to enter the body cells. If left unchecked, hyperglycemia can lead to nerve damage, kidney damage, and blindness. The only lasting solution for individuals with type 1 diabetes is to use insulin injections, which can become tedious, uncomfortable, and expensive. Diabetes has astronomical effects in terms of the health and the cost of care for those who suffer from it, with estimated yearly costs for treatment amounting to $14 billion. Unfortunately, long-standing opinion has been that type 1 diabetes cannot be prevented. Until now. A recent startup company is proposing a method to reduce people's susceptibility to type 1 diabetes. I had the opportunity to ask some questions about their proposed treatment and its impacts with this company's CEO, Niovi Dolis. She joins me now.
Hi Hannah, thank you for visiting us. Over here at Typo LLC, we're interested in developing a genetic treatment to aid in the preventative care of type 1 diabetes. Our staff is working hard at identifying and synthesizing genetic treatments for type 1, and we are in the initial stages of seeking venture funding. We have begun to make some very promising breakthroughs, which our geneticist will tell you more about. Many of us also have a very personal connection to the disease. My niece, for instance, was diagnosed 3 years ago, and seeing the constant struggle she and her parents have to go through to keep her healthy is very troubling. Our company seeks to prevent such suffering wherever possible, essentially by creating a template which is spliced into the at-risk allele in order to provide the preventative benefits.
Typo also has on staff numerous geneticists uniquely qualified and experienced in the field of genome editing. With the long-standing notion that type 1 diabetes prevention is impossible, we asked them what developments have paved the way for their proposed treatment and how it was made possible. Let's see what they had to say.
Type 1 diabetes is a complex genetic disease bearing multiple factors that contribute to its onset. There are approximately 20 chromosomal regions that are linked to type 1 diabetes, as well as specific environmental factors that cause it to surface, such as nutrition. The key role of genetics in the prevalence of type 1 diabetes provides a unique implication for the disease's prevention and treatment: CRISPR-Cas9 gene editing. The CRISPR-Cas9 system is a function of adaptive immunity, which allows recognition of a specific DNA sequence and subsequent targeting of malicious viruses and plasmids. Although first discovered in bacteria, CRISPR-Cas9 has sparked development of techniques for site-specific genome modification in a broad variety of organisms.
How exactly does the INS gene function in the human body?
The IDDM1 through IDDM8 are loci within the human genome which have been identified as contributors to the phenomenon of type 1 diabetes. Of distinctive note is the IDDM2 locus, a major player in the transcription of insulin gene variable number of tandem repeats. INSVNTR is a gene conveying susceptibility to type 1 diabetes in vivo, for which 2 alleles have been identified: class 1, which are recessive and may predispose to type 1 diabetes, and class 3, which are dominantly protective. Research has already shown that with the presence of at least one class 3 allele, there is a 3 to 5-fold reduction in the risk of developing type 1 diabetes when compared to the risk associated with those homozygous for class 1 alleles.
The insulin gene is transcribed in the human thymus, and transcription levels correlate with allelic variation at the INSVNTR IDDM2 susceptibility locus. There is also a correlation between higher levels of proinsulin in the thymus and the negative selection or deletion of insulin-specific T lymphocytes. These T cells play a critical role in the pathogenesis of type 1 diabetes. The deletion of them provides an explanation for the dominant protective effects of class 3 VNTRs.
The main difference between these class 1 and class 3 alleles? Size.
The INSVNTR class 1 recessive abnormality is characterized by a significantly smaller size, 23 to 63 repeats, as compared to its dominant class 3 allele, having 140 to over 200 repeats. It is suggested that this variable size of INSVNTR influenced the strength of its protective effect. Class 3 alleles are more productive managers of the proteins that play a key role in the pathogenesis of type 1 diabetes. Evidenced by this is the aforementioned reduction in risk of type 1 diabetes onset associated with the introduction of a single class 3 allele. This variation in size of INSVNTR then is a mutation of exceptional interest when considering genomic revisions to combat instances of type 1 diabetes.
So, if we are able to use CRISPR-Cas9 to essentially recognize those class 1 abnormalities and replace them with class 3 alleles in vivo, we can markedly reduce an individual's susceptibility to type 1 diabetes. It's just that easy.
The team intends to use the CRISPR-Cas9 homology-directed repair techniques to efficiently replace class 1 VNTRs with class 3. This will be administered embryonically with hopes of providing preventative benefits for those at high risk for type 1 diabetes. The team notes that there are some risks of downstream effects, many of which are relevant to the type 1 diabetes process. They hope to mitigate this by providing relatively specific guide RNA for the CRISPR system, but further research will be necessary. There are, however, threats to these furthered efforts.
Support is always necessary, especially in such public health endeavors. You can find out more information about our project at typollc.com, and we are always seeking new members to join our highly qualified team, as well as additional funding to be able to delve deeper into these queries and implement solutions. Thank you for your time.
We will be following ongoing developments with Typo in future segments. For now, thanks for watching me, Hannah Sides with PCB News. Next up, how many sex chromosomes do platypi have? Find out when we come back from this commercial break.